Hello student, how are you? I'm Arun sir. Welcome to my channel Tuition Expert. Today in this class, I'll teach you Center of Mass part 2. Student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the iitjee exam and NEET exam confidently with a good rank. Now let's start about the class. Today's class is on Center of Mass part 2. In part 1, I have discussed center of mass for point mass. Suppose m1, m2, m3 different mass are given, point mass are given. Now this is origin, and if r is the position vector of center of mass, total mass of the system is this, then this equal to m1 r1 plus m2 r2 plus dot dot mn rn. Okay, so r1 r2 are individual position vector of mass m1 m2 etc. M is total mass of the system. RCM is position vector of center of mass. This is a continuous distributed mass. This is for continuous distributed mass. What is the center of mass of this body? So for this continuous distributed mass, we take a small element dm, and the position vector of this small element is suppose r. Suppose this is an element dm and position vector of this element is r, then we can write m into RCM equal to, here not point mass is given, a continuous mass is present, that is an infinite number of point mass is present in this body. So we can, here for this we can write m dm into r, because we know that summation addition is the integration of small parts. So here for point mass this expression, and for distributed continuous mass, for continuous distributed mass, this we can write this in place of this. Okay, now what is RCM? RCM equal to dm r by total mass of the system. Now RCM equal to x I plus, if the center of mass has the coordinate x y, suppose this is a center of mass whose coordinate is x cm y cm, so this equal to, and for this dm equal to what? dm into r equal to xi plus yj. If this element has the position vector r is equal to coordinate of this equal to xy, so this xi plus yj divided by m. So for this we get, from this we get now, if we equating coefficient of I and j on both sides, we get so this is the formula for distributed continuous mass system. This is the formula of center of mass, coordinate of center of mass for distributed continuous mass. Suppose this is a body, continuous mass is distributed continuously, no point mass are there, infinite number of point mass distributed throughout the body. For any regular body, we can imagine that infinite number of point mass is distributed throughout the body. Now here, if we move along this direction, for this body, if we move along this direction, then mass is continuously increasing there, that is, it is not regular. This body is not regular. For regular symmetric body, center of mass is the geometrical center of the body. Suppose this is a disc, this is symmetric, then the geometrical center is center, so this is the center of mass. For square, this is symmetric along x-axis and y-axis. Suppose this is x-axis, this is y-axis, so this body is symmetric about x-axis and y-axis, so center of mass is the origin, its geometrical center, this is the center of mass. Now this is not regular. As we move along x-axis, suppose this is x-axis, this is y-axis, as we move along x-axis, then mass of the body continuously increasing, so this is not regular. So to find the center of mass, suppose this body has length L equal to suppose 10 meter, L equal to 10 meter. Now the mass is increasing, that is linear mass density. Mass per unit length of the body is given by linear mass density equal to this is given. Now what is the center of mass? Find center of mass of the body, find center of mass of the body. So to find, we apply x equal to xdm by total mass. Total mass means xdm divided by dm. So we apply this, and if this is x and this is y, now along y axis this body is symmetrical, because if we consider this element, then this length and this length are equal, that is along y axis this and this are symmetric about x axis. To find this, this element has length dx, we consider an element x, we consider an element at a distance x from the origin, this is origin. Now what is the mass of this element? What is the mass of the element? Mass will be rho into dx, because this is linear mass density, means mass per unit length. We take the length of this element is dx, so mass of the element will be rho dx. Now what is rho? Rho equal to 2/3 x dx. So m equal to, now xum equal to x dm by dm, which is x dm. What is dm? 2/3 x dx divided by 2/3 x dx, which is equal to 2/3. Now here x is varies from 0 to 10, x is varies from 0 to 10, 0 to 10. Now we can integrate this 2/3 x square. X square means x cube by 3, 2/3 x square by 2, 0 to 10. So we can find axiom. Putting this, we can find the value of axiom. So we apply this theory. This is the formula. Of center of mass of semi-circular ring. Calculation of center of mass of semicircular ring. If we consider ring, this is symmetrical about x-axis and y-axis, this body, so center of mass is at the center. But if we consider semicircular ring, suppose this is a semicircular ring, so if we take x-axis along this direction and y-axis along this direction, then it is symmetrical about y-axis. So x coordinate of center of mass will be on the y-axis. X coordinate of the center of mass is along y-axis. So center of mass will lie on the y-axis, here or here, at which positions, at particular which distance on the y-axis center of mass is present, we calculate this. Semicircular ring. To find the center of we first consider an element. Suppose this is an element, we take this element, and this element we consider at an angle theta. This element we take this element at an angle theta, and this angle is d theta. This angle is d theta. Now what is the mass of the element? Mass of the element will be mass per unit length. Here mass is distributed along the length of the circumference, so mass per unit semicircumference is pi into So here mass equal to mass of this element equal to mass per unit length. What is mass per unit length? Mass, here length is circumference, semi circumference, that is semi circumference is pi r into this is mass per unit length into length of this element. What is the length of the element? Length equal to length of this is arc of the circle. Arc of the circle length is r into d theta, r into d theta. So r cancel, this value will be m by pi into d theta. Now this is theta. Now suppose what is the coordinate of this element xy? What is x and y? So this is theta, this is r, then x equal to r cos theta, this is r cos theta. From trigonometry we get this is r cos theta, and this is r sin theta, this is r sin theta, this is r sin theta, r sin theta, this is r cos theta, and this is r cos theta, this is r sin theta, because from trigonometry we get cos theta equal to, suppose this length is base by r, so base equal to, this is x, suppose x by r, so x equal to r cos theta, and sin theta equal to y by r, and sin theta equal to y by r, so y equal to r sin theta, so the coordinate of xy equal to r cos theta and r sin theta. Now x coordinate of this element xom equal to x dm by total mass is m. Now x, what is x equal to r cos theta into x is r cos theta into dm equal to m by pi d theta by total mass. Now angle is from 0 to pi. Angle varies. To calculate this is dm. So for total semicircle, the theta must be varies from 0 to pi. So here 0 to pi. Now what is the value of mm? Cancel, pi r by pi, cos theta d theta integration is sin theta 0 to pi, so sin pi 0, sin 0 0, so this is 0. So that is x coordinate of center of mass will be 0. Now to find y coordinate, ycom equal to ydm by m. What is y? Y equal to r sin theta dm equal to, what is dm? M by pi d theta divided by total mass, which is equal to mr by pi, which is equal to mr by pi. Sin theta integration is, here theta varies from 0 to pi, again 0 to pi, so sin theta d theta integration is cos theta minus cos theta 0 to pi. So the value is minus mr by pi cos pi minus cos 0, that is divided by m, which is equal to m r by pi cos pi minus 1 minus 1 minus 2, that is 2, minus 1 is cancel, so cancel, that is 2r by pi. So y coordinate is 2r by pi. Y coordinate of center of mass for semicircular ring is 2r by pi. So at a distance 2r by pi, center of mass is present. You can calculate this way. Now for semicircular disc, semicircular disc. So for complete disc, this is symmetrical about x and y axis, so center is geometrical center, that is 0 0. But for semicircular disc, the disc is symmetrical about y axis, so center of mass lies on the y axis, but it is not symmetrical about x axis, so it must, center of mass lies on y axis. And because here diameter, here the length is diameter, here length is small, here length is more small, so this is not symmetrical about x axis. from the x-axis the length is gradually decrease. Length of this value gradually decrease from x-axis. So it is not symmetrical about x-axis, but it is symmetrical about y-axis. So center of mass lies on the y-axis because this body is symmetrical about y-axis, not symmetrical about x-axis. So now what will be the distance? What is the distance of center of mass? We have to calculate. So for semicircular disc, this is y-axis, this is x-axis. Now take an element. We consider as elementary ring. First we consider a elementary ring. Suppose we consider an elementary ring. First we consider an elementary ring which is at a distance y. Suppose this distance is y and the length of this elementary ring and the thickness of the elementary length is dy. Okay. Now dm is the mass of the elementary ring. So to find the mass of the elementary ring, first we calculate mass of this elementary ring. The disk is m, mass of the disk m and radius is r. This is given. So dm equal to first mass per unit area. What is mass per unit area? M by pi r square by 2. This is mass per unit area because area is pi r square by 2. Now what is the area of this semicircular ring? Area of the semicircular ring, if open this elementary ring, then this value will be pi y and thickness is dy. So area is dA equal to pi y into dy. This is the area of this elementary semicircular ring. So area of this pi y dy, this is mass per unit area into area equal to dm. So cancel this pi 2m by r square y dy. This is dm. Now what is the center of mass of this ring? The center of mass of this ring will be 2r by pi. 2r, r is here y. The semicircular, this elementary semicircular ring has the radius y. So the center of mass of this elementary ring is 2r by pi. Here r is y, so 2y by pi. This is the center of mass of this elementary ring. Now to calculate the y coordinate of center of mass of the whole semicircular disc, this will be dm into this 2y by pi dm into this. Now write the value of dm, 2m by r square y dy into 2y by pi. Now here y varies from 0 to, so here we consider the whole mass is considered at this point, dm into y. So dm into this distance is 2y by pi. So this here we consider that whole mass is concentrated here at the center of mass of this elementary ring. So we take dm into this distance divided by total mass m, Here y varies from 0 to r. So this, if we calculate this, then this will be 4m by pi r square y square dy, integration of 0 to r by m, cancel this. So pi r square y square dy is yq by 3 into 4 0 to r. So 4 rq by 3 pi r square into r square cancel. So this will be 4r by 3 pi. So this is the answer. Okay, YSUM equal to 4r by 3 pi. Here center of mass is present at this distance r by 2. Here this distance is r by 2. If radius is r, then center of mass is present at here at r by 2. Now for solid hemisphere, for solid hemisphere, this distance will be center of mass 3r by 8. What is the formula? 3r by 8. Hemisphere, this location is 3r by 8. For hemispherical cell, center of mass is r by 2. These are the formula. Now next topic is rocket propulsion. Rocket propulsion. Next topic is rocket propulsion. So for rocket, we have to find the velocity of the rocket after t second from the launching. For rocket, suppose the rocket starts t equal to 0, mass of the rocket is m0 and velocity v equal to u. When the rocket starts, the mass is m0 and velocity equal to u. Now after t second from the launching, t equal to t, mass equal to v, and after t second velocity of the rocket equal to v, initial velocity u, and vr equal to relative velocity of exhausting gas, exhausting velocity of existing gas, and we define dm by dt equal to rate of ejection of gas. dm by dt equal to rate of ejection of gas, vr equal to relative velocity of existing gas. Now the rocket starts. So after t second, what is the velocity of the rocket? We have to find this. Now when the fuel ejects from the rocket, then it exerts a thrust on the rocket, which is ft. It exerts the thrust on the rocket, which can lift the rocket. Now weight of the rocket is m equal to mass of the rocket, Suppose at t second, mass of rocket, total mass of the rocket including parts and fuel, m equal to mass of rocket at t second. Now thrust, due to ejection of the gas, thrust is act on the rocket, and weight of the rocket act downward, and thrust act upward. So what is the value of the thrust? Ft equal to thrust act on the rocket, which is value of minus Vr dm by dt. Here Vr is velocity, relative velocity of existing gas with respect to rocket, and dm dt is rate of ejection of the gas flow. Now if dm by dt, this will upward, this direction will be upward, because if Vr is along this direction, Vr is along this direction, and dm by dt is negative, so ft will be positive. So if Vr is along this direction, ft will be upward. Actually this is positive sign, because Vr is already negative. Negative into negative is positive, so this is positive sign, so this is upward. Now thrust equal to, the thrust has the value of this, Now total acceleration at any moment, mass into acceleration, equal to thrust minus mg. This is the equation of motion for the rocket. Mass is at t second, m equal to mass of the rocket, thrust minus mg. Now if we A equal to ft by m minus g. Now what is A equal to dv by dt, dv by dt equal to ft. What is ft? Ft equal to this, ft has the value of this minus dr dm by dt into m minus g. Now dv equal to what? Dv equal to dt minus vr into dm by m minus g dt minus gt. Okay, so if we integrate now dv by dt equal to this, if we so dv equal to minus vr dm by m minus g into dt. If we integrate both sides and take the limit when t equal to 0, mass equal to m0, velocity equal to u, when t velocity mass m and velocity equal to v, so dv integration is v u to v equal to minus vr log m m0 to m minus g into t. So v minus e equal to minus vr log m minus log m0 minus gt. So from this we get v equal to, u minus vr log m by m0 minus gt. So v equal to u minus gt minus vr, okay, minus vr log m by m0. So this is the answer. So velocity at t second, velocity of the rocket at t second after launching is this value. Here vr is the relative velocity of the exhausting gas with respect to the rocket. So v equal to this value, v equal to u minus gt minus vr of this. Vr is the relative velocity of the gas, exhausting gas with respect to the rocket. U is initial velocity of the rocket after t second. This is the expression of the velocity of the rocket after t second from the launching. m0 is initial mass, m is mass of the rocket at t second. So this is the final expression. Now here is a problem on the rocket motion. A rocket set for vertical firing. A rocket set for vertical firing weighs 50 kg. That is, this is the weight of the rocket. Instrument and its body structure contains 550 kg of fuel. It contains 550 kg of fuel. It can have a maximum exhaust velocity of 3 km per second. So what should be the minimum rate of fuel consumption and to just lift off the launching pad to give it an acceleration of 30 meter per second square? What will be the speed of the rocket when the rate of consumption of fuel is 10 kg per second after whole of the fuel is consumed? So here we use the formula of this v equal to u minus gt minus vr log m by m0. This is the formula for rocket motion. So what are given in the problem? First we write what are the given in the problem. Here initial mass m0 equal to total weight of the initial mass is 50 kg plus 550, that is 600 kg is the mass of the initial mass of the fuel. Now relative velocity vr equal to 3 km per second. This is meter per second. Okay, now minimum rate of fuel consumption, that is dm by dt we have to find. First dm by dt equal to what? Rate of fuel of gas consumption we have to find this when it has just lift of the launching pad. So first solution of the first problem, to just lift of the launching pad. What is the condition for launching of for lift of the launching pad of the rocket? Suppose this is a launching pad. If the rocket have to be lift from launching pad, the thrust exert on the rocket must be equal to the weight of the rocket. So this is the condition, that is thrust force must be equal to mg for lift of the rocket at launching pad. This should be equal to weight. Now what is ft? Ft equal to Vr into magnitude of this, magnitude of thrust, Vr into dm by dt equal to mg. So relative velocity here giving Vr equal to what? 3 into 10 q, and dm by dt we have to find this equal to mass, total mass of the rocket equal to 600 into g equal to 10, take g equal to this. So this is the answer. 2 kg per second, 2 kg per second. So this is the answer. So first answer we get that what is the condition for lifting of the rocket at launching pad? The condition is thrust equal to weight of the rocket. Thrust, what is the formula of thrust? Formula of thrust is relative velocity into dm by dt equal to mg. We have to find dm by dt. Vr is given, mass is given. So this is the first answer. Second answer, what is the second question? To give it an acceleration of 30 meter per second, what is the value of minimum rate of fuel content? Now to give the acceleration of 30 meter per second to the rocket, the rate of fuel consumption should be increased. So what is, so suppose this is a rocket, dm by dt rate of exhausting gas, so thrust act in this direction and weight act in this direction. So equation is ft minus mg equal to ma, ft equal to minus vr, magnitude is this dm dt, we use here magnitude, minus mg equal to ma. Now vr equal to what? Vr equal to this dm dt we have to find equal to a plus g. Here g is 10 and a is, what is a is 30 meter per second square. 30 into mass of the rocket is 550 plus 50, this is the mass. So from this we get dm by dt. This is one answer. So answer of 2 is this. Now what is the third question? What will be the speed of the rocket when the rocket of consumption of fuel is 10 kg per second? When the rate of, here dm by dt is given and speed of the rocket, what is the velocity of the rocket? So we have to use this formula. When all the consumption of the fuel, after whole of the fuel is consumed, so what is the time after which whole the consumption whole fuel will be consumed? So what is the time after which whole fuel will be consumed? The time is total mass of the fuel is 550 divided by rate of mass fuel. What is the rate of mass fuel? Rate of mass fuel is 10 kg per second, 10. So total 55 second is that. So after 55 second whole fuel will be consumed. So t equal to this. Now velocity equal to u, initial velocity equal to initial velocity of the rocket. So what is the m0 here? M0 Initial mass is 550 plus 50, that is 600 mg, and m, when whole mass of the fuel is consumed, then remaining mass of the rocket, that is 50 kg, is present. So here m equal to this and m0 equal to this. Now put here u equal to here 0, u equal to 0. Now put the value of this, we get minus this value of minus Vr equal to what? This into log m 50 by 600 minus g equal to 10 into t equal to 55. So this will be so log 12. There is a value of log 12. This is the answer. So velocity after t second is this. Student, this is the end of the class today. To get important problems related to center of mass, watch my another video. Okay, thank you.